Hello and welcome. We see these numbers in the news literally every single day, but we don't always stop to think about what they are. I'm talking about index numbers. Today, we're going to break down exactly what they are, how they're made, and why they're so important. You hear it all the time, right? The consumer price index is up, the market took a dive. These are huge, sweeping headlines, all driven by a single number that's supposed to tell this massive story about the economy. But how do they do that? How do you boil down all that complexity into just one figure? Well, let's find out. And you definitely know some of these names. The CPI, that tracks what you and I pay for stuff. The Sensex and Nifty, they follow the stock market. Every single one of these is a type of index number, and they're all designed to give us a quick snapshot of a very complex system.
So how can one number possibly capture so much information? That's really the magic trick we're diving into today.
Okay, so at its core, here's the official definition. But a better way to think about it is like a specialized average. Instead of just adding things up, an index helps us compare changes between two different points in time, like, say, this year versus 5 years ago.
And believe it or not, this is not a new idea. Not at all. The concept actually goes back centuries. I mean, people have always needed a way to measure economic change. Way back in 1707, this guy, William Fleetwood, was basically creating an early version of a cost of living index just by tracking the prices of things like wheat and beans. All right, so to really understand how an index works, we've got to look at its essential parts, its building blocks. Let's break them down. Everything starts with two really key ideas, the base year and the current year. The base year is our starting line, our benchmark. It's the normal that we compare everything against, and we just decide its index value is always 100. The current year is, you guessed it, the period we want to measure against that base. So here's the key takeaway. If you see an index of, say, 110, it just means there's been a 10% increase compared to that base year. Simple as that. So if we pull all these ideas together, you can think of index numbers as these specialized averages that we always express as percentages. Their entire job, their whole purpose, is to measure change. That is why they get called barometers of economic activity. Because, just like a weather barometer, they help us see which way the economic winds are blowing. Okay, theory is great and all, but let's make this real. We're actually going to build our very own simple price index right now. All right, here's our data. We've got 4 different items and their prices in our base year, 2010, and our current year, 2015. Our mission? To distill all 8 of these numbers into one single index number. The math for a simple index is, well, it's simple. First, we just add up the prices in our base year, 2010. That gives us 220. Then, we do the exact same thing for our current year, 2015, which totals 300. And finally, we just divide the current total by the base total and multiply by 100. That's it.
And there we have it, 136.36. This one number tells us that, on average, the prices for this little group of items went up by about 36.4% between 2010 and 2015. It's a perfect example of how we can take a complex change and simplify it into a single, understandable figure. But, of course, the real world is always a little more complicated. That simple index we just made, it has a pretty big flaw. It treats every single item as equally important. So what happens when they're not?
A simple index just treats every item the same. But think about your own life. Is a change in the price of your housing as important as a change in the price of movie tickets? No way. A weighted index solves this by giving more weight or importance to the more significant items. And that makes it way more realistic.
Now, one of the most famous ways to do this is something called the Spires Index. It figures out an item's importance by looking at how much of it people bought way back in the base period. The logic is basically, let's measure the cost of the exact same basket of goods over time. It's a really foundational method for creating a lot of the big economic indexes we still use today.
So we know how they're built, but why do we even go through all this trouble? Let's take a look at the real-world impact. So why are they so crucial? Well, because they drive decisions at pretty much every level. Governments use them to shape policy, businesses use them to try and forecast the future, economists absolutely rely on them to measure inflation, and for all of us, they help show the real value of our money. And a really powerful use for this is something called deflating. Think about it. If your salary went up 5%, but the price index went up 7%, did you really get a raise? Not really. Deflating helps us strip away the effects of inflation so we can see what our money is actually worth compared to before.
It lets us see the change in real terms.
But as powerful as they are, you've got to remember, index numbers aren't perfect. It's so important to understand their limitations. So what does all this mean? It means we have to be critical thinkers, right? An index for industrial production isn't going to tell you a thing about agriculture. It can't tell you if a new phone is more expensive just because it's a much better phone. And those weights we talked about can get outdated as our spending habits change over time. The bottom line is, no single index is a perfect mirror of reality.
So we'll end with this question. An index number is an absolutely amazing tool for simplification. It takes a whole mountain of data and gives us a single tidy number to guide us. But the next time you see that headline about an index going up or down, just ask yourself, what's the bigger story here? What important details might this one simple number be hiding? Thanks for joining us.